So today we're going to start section 9.3, and we're going to work on 9.3 all this week. We're going to do reference angles today. Tomorrow we're going to do what I consider to be like the most challenging part of 9.3, and that's figuring trig ratios without a calculator. And Thursday we'll spend time reviewing Tuesday and Wednesday's material. So we'll spend an extra day with what we do tomorrow because it's one of the more challenging parts of the section. And then Friday, we'll have a short set of notes on calculating trig ratios for any angle on a coordinate plane. Okay. So we'll do 9.3 all 4 days this week. And then next week on Monday, we'll review 9.3. On Tuesday and Wednesday, that's block scheduling because our juniors will be taking the NISA writing test during English class. And so we'll have a quiz on that block schedule day. And then the rest of the time in class, you'll be reviewing for your test. Thursday will also be test review. And Friday of next week is your Chapter 9 test. So if you like to plan ahead, we're working this week. Next week, we're reviewing, quizzing, and testing. So reference angles are something that's going to be very useful to us tomorrow. Today, we just have to kind of wrap our heads around what is a reference angle. Here's the definition of a reference angle. I'll give you some time to go ahead and write it down. So there's a couple of really important things about the definition.
I have a question about prime. Isn't it if you move something towards the double prime?
Yes, back in geometry, so like let's say you had an image, ABC, a triangle. You reflected it over the y-axis. So you got that would have been the pre-image. Then you have the image, A prime, B prime, C prime. And then you translate it left 3 up 2. That would be double primes. We won't have double primes with trig. So we'll only work with theta prime. But there are a couple of really important things about the definition. First of all, you'll know you have a reference angle when your angle is acute. So think about what you know about acute angles. What has to be true of acute angles? Less than 90? Greater than 0. So I would also maybe add to this, we'll know we found the proper reference angle when it's also positive. Because we know now in Algebra 2 that negative angles are an option. Okay? And our reference angle should always be the positive acute angle. So numbers like 1, 2, 3, 10, 20, 30, 40, 45, 60, those are going to be examples of reference angles. The other important piece from the definition is the reference angle is formed by the terminal side. So that's wherever your angle opens, wherever that side lands, in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. It's formed by that terminal side and the x-axis. A rookie mistake when finding reference angles is to go back to the y-axis. So we want to try to avoid that. Be aware of that. That's a common thing for people to do. We don't ever want to go back to the y-axis. We want to go back to the x-axis in the shortest amount of degrees as possible. Okay, so we're going to draw 3 different pictures. The first picture is going to be of some angle in quadrant 2. And I'll kind of walk through and draw the angles with you, trace over this. This is like the picture from page 480. So I would start by drawing my x and my y-axis. And then I would draw my angle in standard position. So I have an initial side on the positive x-axis. And like I said, your terminal side is going to land somewhere in quadrant 2. That represents this red angle, which we're calling theta. Now, I'm going to use green to show my reference angle. So, remember, the reference angle has 2 sides. One side is the terminal side of the angle, The other side is the x-axis that's closest to that terminal side. Okay, so when I'm drawing my reference angle, I go to my terminal side first. There's one side of my reference angle. And then the closest distance to the x-axis is at the 180 mark. So there's my reference angle right here. And I'll label it a little bit bigger. That's theta. So the red angle was original theta. The reference angle is the theta prime. Okay, so we're going to think about this logically so that we can write the rules for the different quadrants. Do I have someone who can estimate the measure of the red angle, theta? About how many degrees do you see in theta? Faith? 155? Okay. Faith says it's a 155 degree angle. Are you okay with her estimation? Eric says, yeah. Jackson, Lauren, they're saying yes. I'm okay with it. It's between 90 and 180, right? We at least know that. So 155 seems like as good a guess as any. If this red angle is 155, how can you find the measure of the green angle? Jackson?
You can take that number 180.
Take that number, 155, and subtract it from 180. Do you agree with that? Does anybody have a reason they'd like to give for why that works? Jace? Oh, the two quadrants that the two angles are in add to 180 and there's no extra space. Does anybody remember what angles are called that are adjacent and make 180 degrees? A linear pair from geometry. So we have a linear pair. Okay, so we can use some of the information from last year. So Faith had mentioned if it were 155 degrees, and then Jackson said we would do 180 minus 155. Will that work if we estimate that angle differently? So does anybody think they would estimate the angle a little bit differently than 155? You would call it, what's that? Oh, you could do it in radians. What about in degrees? Is it absolutely 155? No, could someone have said 140? And we would have said that's just as reasonable. It's between 90 and 180, and who knows, we're estimating, right? Would we have done the same thing if this red angle were 140 and we wanted to find the measure of the green angle? Would Jackson's method work again? 180 minus 140? Riley says yes. So this is the rule we're going to write down. In quadrant 2, theta prime, the reference angle, is equal to 180 minus theta. If theta is 155, then our reference angle will be 25. If theta is 140, then our reference angle will be 40. But I think we're all in agreement that those two angles should add up to 180. So that's the rule we're going to use going forward if we're in the second quadrant. Rule changes in the third quadrant. So we'll draw a new picture. Draw yourself an X and a Y axis. Draw an angle in standard positions whose terminal side lands somewhere in the third quadrant. So I have a positive x-axis for my initial side. I want to open in the third quadrant, so I have an angle here. And that represents this red angle, which we'll call theta. And we're working now in quadrant 3. Think visually about what the reference angle would look like. And remember, the reference angle is always made up of the terminal side and the x-axis. So I'm going to trace that in green. Terminal side of my angle. The x-axis that's closest is to go back to 180. To go to 360 would be not acute. So I'll go back to 180 here. And this will be my reference angle, theta prime. So this changes. Our picture looks a little bit differently. Are the two angles making a straight line anymore? Not really. And what's really interesting is they're not really considered like adjacent angles. That one reference angle is almost overlapping the other one. Right? It's like inside of theta. So what can we change about our process if we're trying to find the reference angle? Eric, what are some things that are going on in your head?
You can subtract 180 from theta, so subtract theta.
What do you think about Eric's idea? Does that make sense to you? Yeah. He said subtract the 180 from theta instead of theta from 180. So that's going to be our rule. And now I'm going to ask, is there someone who can tell us why that works? Or like what you're thinking about? Several people were shaking their head and saying, yeah, I agree with that rule. Why does that rule work here? Kira?
Because quadrant 1 and 2 already equal 180, and so that extra part is just
Oh, I love that. Quadrant 1 and 2 add up to 180, and all you're looking for is the extra stuff. Did someone else have a different way of thinking about that? Jackson?
Quadrant 1 and 2 are positive, and 3 and 4 are negative. You're going on the y-axis.
Yes. How does that relate to then doing theta minus 180?
Because then you're going to get a negative.
If you did it the old way?
If you do theta minus 180, then you're going to get a negative number because theta has to be lower than 90.
Oh, 90.
Isn't that what we're trying to show?
Oh, yes. Theta has to be a positive acute angle. Okay, I understand now. So he's saying if you kept the same rule, right? Make sure that I'm getting this right. If you kept this rule and then you used it in the third quadrant, you'd come up with a negative number, which does not agree with our positive acute angle. Okay. Anybody else have an idea or thought they'd like to share? I love the way that Sierra put that into words. That was great. Okay. Now, there's one other picture to draw. Where are we going to draw it? Quadrant 4. And you can guess what this picture is going to look like, right? Draw yourself an XY axis. Get yourself an angle in standard position whose terminal side is somewhere in quadrant 4. So we have an initial side on the positive x-axis. Our angle must open above 270 degrees so that we're somewhere in the fourth quadrant. We've got a terminal side there in the fourth quadrant. And that's our angle marked in red, our theta. And then to help us create our rule for the fourth quadrant, we want to think about what's that reference angle. Remember, the reference angle is made up of the terminal side and the x-axis. So terminal side and the x-axis. Now I'm going back to the positive side. Because if I went back to where we were going before at the 180 mark, that wouldn't be an acute angle anymore. So we got to go up to the positive side. So there's my theta prime. We're in quadrant 4 right here. I'd like for you to have a quick discussion with the people sitting next to you. How would you write a rule in the fourth quadrant? And if you're having trouble, think about like what could be a number for theta, and then how would you find theta prime? So I'll give you a quick minute to discuss. So I went around and I talked, and we approached it in different ways. And one way that I suggest thinking about, just to like create the rule on your own, is to, like give the angle, the red angle, a measure. Sometimes when you change it from just like a theta to a number, that makes it a little bit easier. So I think I told Eric and Juliana, I gave them that hint. And what did you guys estimate theta to be?
About 285 degrees.
285 degrees. Did that help you guys kind of come up with a plan? What'd you do?
Either 360 minus the
Yeah, so then they said, okay, well, if that was 285, what's left over? Let me just do 360 minus 285, and I'll have what's left over. And then Jace kind of wanted to describe, how do you decide that it was going to be 360?
Because, like, you use the whole coordinate around 360, so then if you just took 360 minus the one part, you'd get what the normal side would be.
Yeah, there was some issue in like, do I have to use theta? Do I have to use theta prime? I would argue yes, but I told a couple groups, you don't have to use 180 every time. And so do we want to use 180 at all in this rule? No, because if you look at the green parts that we drew, none of those parts have anything to do with 180. This is the terminal side of the angle, and this is now what Jace was saying, all the way around is 360. So we should write a rule that says theta prime is equal to 360 minus theta. Now, there's one sort of caveat to the rules that we wrote. The rules that we wrote only work if your theta is within one revolution, between 0, between 360. So we should make a note of that in our notes and say this works for thetas that are greater than or equal to 0, but less than 360 degrees. The rules don't really apply, this 180 minus theta or theta minus 180, if the angle is over 360 or if the angle is negative. Okay. So in cases of negative angles or angles over 360, okay, use coterminal angles. And think back to your quiz that we talked about at the beginning of class. For coterminal angles, we'd be adding or subtracting 360 as many times as necessary to get it in that range. Thanks.
I have a question. This one doesn't work.
Okay, give me 1 second. So we have to make that rule that we would use coterminal angles. The other thing that you might want to make note of is we're going to focus on degrees. So in this section, if we get something in radians, we're going to do a conversion. Okay, so we would multiply by 180 over pi. Okay, let me go to the next slide, and we're going to practice finding coterminal angles. So if you would start by sketching the angle, and then talk with your partner or people around you how you think you might be able to find the reference angle for 260. It's really close to 270, right? How do you find the reference angle in quadrant 3? You subtract 180 from it, so we'll take 260 minus 180, which is 80. Is that positive? Is that a cube? So it's a reference angle. Good. Can you work on 7 pi over 5? And think about what I said. For this section, it's okay if you change it into radians. So work with the people around you. You can leave it in degrees. Okay, I would start this one by changing it into degrees. So we're going to say 180 over pi. We're going to put radians on the bottom to cancel out the radians. The pi's will cancel. You could do in your calculator 7 times 180 divided by pi. Or you could cross cancel 180 and 5. What is this number? 252 degrees. So which quadrant will that lie? Again in quadrant 3. And so the rule for finding the reference angle would be the same, right? We'd still do the angle minus 180. So we could say our reference angle, theta prime, is equal to 252 minus 180, and that's equal to 72. You don't, on this one, I'm okay if we leave it in degrees, because you'll see tomorrow why we want them to be in degrees anyway. It has to do with those special right triangles we talked about at the in class. Okay, the last one that I want to show you, and you can choose to write it down in your notebook, or just kind of follow along with us on the board, is one where the number doesn't fit. So remember, I had said on the previous slide, make sure it's between 0 and 360 or 0 and 2 pi. It should be in that range. If not, use coterminal angles. So what if I change that first problem, instead of doing positive 260, what if I change it to negative 260? My rules, like 180 minus theta, theta minus 180, 360 minus theta, they don't apply unless that's between 0 and 360. So the first thing I would do here is say, I want this to be between 0 and 360. So I'm going to find a coterminal angle. And this we practiced on our quiz. Take negative 260 plus a full revolution 360, so the new angle is 100. Can you graph a 100-degree angle? Sure. It's in the second quadrant. And then think about where your reference angle is, going back to the x-axis. How do you find that reference angle in quadrant 2? 180 minus theta. So we would do 180 minus 100, which is 80 again. Is it positive? Is it acute? It's a reference angle. So keep that in mind, that you can use that coterminal to make your life a little bit easier. Okay. Your homework assignment for this evening is here.